ACS Primary Topical Test 2, Section A, where calculators are not allowed. So get question 1. There are some red, yellow, and blue buttons in a jar. The ratio of the number of red to the total of blue and yellow is 4 to 7. The ratio of blue to the number of yellow is 2 to 3. What is the ratio of blue to red buttons? Okay, so for this question, let's write down the ratios that the question gave. So we have red to the total of blue and yellow, which is 4 to 7. Then the other ratio that we have will be blue to yellow, 2 to 3. Okay, so between the two ratios, you need to find common base, okay? Or some may call it repeated identity. So your common base in both ratios will be the total of blue and yellow. So your blue and yellow over here is 7 units. Your blue and yellow here would be the sum of 2 and 3. So I will write B plus Y. Instead of writing total, I write B plus Y. Okay, because total may mean like you add red as well. So B plus Y here is 5 units. You want to make it the same. They represent the same thing. It's the sum of B and Y. So you want to make your common base the same. 7 and 5 to make it equal. You'll find a common multiple of 7 and 5, which is 35. So here times 5, I get 20 to 35. Here to get 35, I will times 7. Okay, so 14, 21, 35. Common base equal. Now they're asking for the ratio of blue to red. So blue to red, blue is 14, red is 20. We simplify this, divide by 2, you get 7 to 10. Okay, so answer is option 4. Question 2. In the figure below, ABDE is a square, CDE is a straight line. You have 29 degrees. Find angle CBE. Okay, this angle over here. So firstly, we have a square. Their sides are all the same. And if you have a square and the line, diagonal line cuts through it, this would be 45. Here, you will cut through the right angle, cut it by half. Only works for a square, not a rectangle. Okay, so to find angle CBE, we look at the triangle CBE, which is 180 degrees. Okay, sum of angles in a triangle is 180. Then I will add 45 and 29. Which is 74 degrees. So these two angles will be 74. This angle here will be 180 minus 74. Which will be 106 degrees. So answer 3. Question 3, figure below shows a square in a quadrant. Find the perimeter of the shaded part. Now, the shaded part is made up of two straight lines, which is this 14, and the arc of a quadrant here. Okay, so you need to find the arc of the quadrant. To find circumference of a circle would be pi times diameter. So if this is the arc of a quadrant, is 1/4 of that. So 1/4 times pi, your pi is 22/7, times the diameter. So the diameter is 28. Because 14 is the radius. This is without calculator, so this is how you calculate. So 4 and 22 we can simplify, or 4 and 28 also can. So let's say I do 4 and 28. I'll divide by 4, divide by 4. I get this. Now I have a 7 in the denominator, 7 in the numerator. Both can be simplified as well. Okay, both can cancel. Divide by 7. So you're just left with 22. Okay, 1 times 22 times 1 is 22. Denominator is just 1. So answer 22. Not final answer, but the arc is 22. So the total perimeter is 22 plus 14 plus 14, which is 15. Answer 4. Question 4. In section B, again, no calculators. So figure below is made up of a semicircle diameter 14 cm and a triangle. Find the area of the shaded part. Now the shaded part is actually a semicircle minus triangle. Okay, and the triangle has a base of 14 and a height of. Now the height of the triangle is actually the radius of the semicircle. So if the diameter is 14, then the radius would be 7. Okay, radius. Radius 7 cm. If you want to find the triangle, half times base times height, which is 49. Then semicircle, the semicircle, so it's half of a circle, so half times height, which is 22 over 7, times radius. Simplify, this is 7 and 7. 2 and 22 becomes 1 and 11. So numerator will just be 11 times 7. Okay, denominator is just 1. So 11 times 7 is 77. 77 over 1 is the same as 77. Now, area of semicircle minus triangle. So 77 minus 49. Answer 28 square cm. Question 5. At a carnival, the ratio of adults to children was 3 to 5. The ratio of men to women, 2 to 3. What's the ratio of men to children? Okay, so A to C, adults to children, 3 to 5. The ratio of men to women, 2 to 3. So what is your common base? What is something that can be found in both ratios? So men and women, when you combine them, you call them adults, right? So the sum of this will be adults. So that is actually a common base, adults. So men plus women is a 5. Adults here, 5. Adults here, 3. They are referring to the same thing. So what we want to do is to make a common base equal by finding common multiple. Common multiple of 3 and 5 is 15. Okay, 15. So the first one you multiply by 5, so you get 25. Then the other one you multiply by 3, so 6, 9, and 15. Okay, so you want a ratio of men to children. Men is 6, children is 25. Okay, so take note that I only find what I need to find after your common base is the same. Question 6. The figure below is a rhombus PQRS, and you have this angle 32 degrees. Find QRS, which is this marked angle over here. So for a rhombus, you have 4 equal sides, which may or may not be useful for the question, but just mark it out. And then you have 2 pairs of parallel lines. Double arrow to indicate the second pair. Now, if you can actually use the alternate angles, which is the Z. Like that. Okay, this only applies if you have parallel lines, which we do, PS and QR. So then I know that this one here is 32 degrees. Then because I've drawn these two lines to indicate that they are equal, then I know that this is actually an isosceles triangle, which means that this angle here is also 32. So 32 times 2. Then to find this angle here that we want, we take the triangle, which is 180, minus away 64. Answer 116 degrees. Okay, now question 7. And this is section C, for which calculators will be allowed. If the figure shows 3 identical semicircles, AB is a straight line. Diameter of each semicircle is 10 cm. Supposed to find the perimeter of the figure. I'll give your answer in terms of pi. Okay, so one semicircle arc, the arc of a semicircle is half times pi times diameter, which is 10. Okay, let's find that first. One semicircle arc, half times pi times 10, because they want us to leave answer in terms of pi, so you have to leave your pi there. So over here you have half times 10. Half times 10 is 5. 5 times pi is 5 pi. So this is 5 pi. And you have 3 of them. So 5 pi times 3, which is 15 pi. Okay, 5 pi, 5 pi, 5 pi. What's missing is your 10, 10, 10. So total perimeter would be 15 pi plus 30, which is just 15 pi plus 30, okay? So that's the answer. Because the whole thing is in cm, I'll put okay. Okay, question 8. Figure below is made up of a right angle ABE and isosceles triangle ADE. Then you are given angle BAD. Okay, this angle here, 31 degrees. Find angle X. Now what we can find first is angle DAE. DAE, because this is 90 degrees, this is 31. So I'm going to find this. Okay, and because they said that ADE, the whole thing is isosceles, means I would know this angle as well. Okay, let's find DAE first, this one. $90 degrees minus 31. 59 degrees. So this is 59. And because this is isosceles, this would be 59 as well. So angle X, 180 minus 59, which is 62 degrees. Okay, so answer 62 degrees. Question 9. Gina, Harry, and Ethan shared the cost of their father's birthday present in the ratio 5 to 3 to 1. Present cost $180. How much more than Ethan did Gina pay for the present? Okay, so firstly, we have the ratio G to H to E. 5 to 3 to 1. Okay, they shared the cost of the present. So the total cost of the present will be the sum of the units. So 5U, 3U, 1U, total 9U, and that is $180. Okay, we are looking for the difference between E and G, which is 4 units. So let's find 1 unit first. Divide by 9, we get $20. 1 unit is 20. So as we were saying, we're supposed to find the difference between E and G, right? So E and G, the difference is 4 units. So 4 times 20, which is $80. Okay, sorry, dollars is given. Question 10. Figure shows 2 identical quarter circles with radius 9 cm. Find the perimeter of the figure. Okay, so perimeter of the figure includes 4 straight lines, right? So 4 times 9 will be part of the working. The other thing we need to find is the arc. So we have a quadrant and then a quadrant. 2 arcs of a quadrant gives you a semicircle arc. So firstly, I need to find the diameter because the formula that we have to find for arcs, right, will be pi times diameter. Okay, so first, diameter would be 9 times 2 is 18 cm. Okay, so 2 quadrant arcs give you 1 semicircle arc. 2 quadrant arcs give you 1 semicircle arc. So I will find 1 semicircle arc, half times pi times half times pi, so pi is 3.14 times diameter, which is 18. Simplify, then key in your calculator, 9 times 3.14, which is 28.26. 28.26. Okay, so, sorry, that one is the semicircle, so it shouldn't be 28.26. The combined one should be 28.26. So this will be this and this. Okay, semicircle. Okay, let's indicate here semicircle. Now you add all the straight lines. So 9 times 4, which is 36, then 36 plus your arcs, total of 28.26. So this will give us 64.26. 64.26 for question 10. Question 11. David has a number of 10 cents, 20 cents, and 50 cent coins in a ratio 1 to 2 to 5. The total value of all the coins is $90. What is the total value of the 50 cent coins? Okay, so in this question, we talk about 2 things. One is the quantity, which is the number of coins. Okay, number of coins. And then in this ratio, then we have the value. Value means like the dollar value of the coins. Okay, so what you can do is using the quantity value table. I'll split this 10 cents, 20 cents, 50 cents, quantity is talking about the ratio given. So 1 to 5. So this whole thing, whatever I'm doing is called one group. In one group, I will have one 10-cent coin, two 20-cent coins, and five 50-cent coins, according to the ratio. Then in terms of value, value means the dollar value of each item. So let's say for 10 cents, right, the value of 10-cent coins is 10 cents, for 20-cent coins is 20 cents, for 50-cent coins is 50 cents. Total value is where we multiply. Example, one 10-cent coin is still 10 cents. Two 20-cent coins will be 2 times 20 cents, which is 40. Then five 50-cent coins will be 5 times 50 cents. 250 cents. Okay, this whole thing is one group. The total value of all the coins is $90. So in one group, I should be finding the total amount of money. Okay, so one group will be 10 cents, 40 cents, and 250 cents. So this will give us 300 cents, which is the same as $3. So in one group, I have $3. My total is $90. How many groups are there? This is a grouping type of question, so you need to find number of groups. Okay, so some students may take 90 divided by 3, but they are not sure what they are finding. So label your steps, label number of groups. This is what we're trying to find. 30. So there are 30 groups. 30 groups, So this whole thing is what we call one group. So what is the total value of the 50-cent coins? Total value of the 50-cent coins is 250 in one group. There's only one group, but I have 30 groups. So I'll take 30 times 250, which is 7500 cents, which is $75. Okay, it's $75. Okay, $75. Next, question 12. Figure below is made up of 4 semicircles. O is the center of the big semicircle of diameter 10 cm. Find the perimeter of the shaded part. Okay, we see like different sizes, different semicircles in different sizes, right? So, but you have too big, too small. Okay, too big, too small semicircles. So what can we find with the 10 cm? 10 cm, you can find this, hold on. 10 cm is the diameter of the semicircle. So this is the arc that I can find. Okay, then we have two of that. Two semicircles. Okay, two semicircles will give us one full circle. So for this step here, the one for the green ones, right? Those will be the arcs of two large semicircles. Just write semi. So this is the same as one full circle. Okay, so if it's one full circle, then you don't have to times half. You just take pi times diameter. So pi, which is 3.14, times diameter of 10. You get 31.4 for the two green lines. Not each of them, but both add up to 31.4. Now you want the smaller semicircle next, which has a different diameter. So let's find the diameter first. If O is the center, means that this part here is the same as this part here, right? So they are equal, which means that the diameter would be 10 divided by 2. So diameter of smaller semicircle, half of 10. So 10 divided by 2. Now, the two blue semicircles, right? They gave you one full circle of diameter 5 cm. So the blue ones will be arcs of two small semicircles. And same thing, this will give us one full circle. So full circle is pi times diameter. And you calculate this, you should get 15.7. Okay, so the two green plus two blue will be 31.4 plus 15.7. So answer 47.1. Square cm. Question 13. In the figure below, we have a trapezium. A, B, C, D is a, sorry, not trapezium, parallelogram. Then you have angle 53, angle 94, which is ADE. Then BDC is 82, find BDE. Okay, so these two angles are overlapping. Your 94 and 82 are overlapping. So firstly, I'm gonna find this. Okay, wait, hold on. I can actually do the alternate angles here because you have parallel lines, right? Parallelogram. So using this, these are alternate angles. This is 94 degrees. Okay, this is 94. I want to find angle EDC. EDC here, which is included inside your 82. Okay, so if I can find this, I can take 82 minus that to get the answer. Okay, so opposite angles of a parallelogram will be the same. So this part here is also 53. So let's find EDC. 180 minus 94 and 53. This will give us 33 degrees. So B, D, E is 82. Oops. 82 degrees minus 33 degrees. 49 degrees. Okay, so 33 is here. Sorry, no, wrong one. 33 is here. So that's why we take 82 minus 33. So answer 49 degrees. Okay, next question. 14 is a bit harder. The ratio of kiwis to pears in a basket A. In basket A was 5 to 8. There were thrice as many kiwis as pears in basket B. Fruit seller transferred 1/4 of the pears from A to B. There were 308 left in A, and the ratio of kiwis to pears in B became 7 to 5. So what is the ratio of kiwis to pears in A in the end? Okay, let's see. What we have here in basket A, 5 to 8. Then you also have 308 left. And of course, we transferred 1/4 of the pears from A. So whatever I've highlighted in pink will be talking about basket A. So at first, basket A, kiwis to pears. A to P, 5 to 8. There is a change in the number of pears from A. Okay, so your pears minus 1/4. But because 1/4 is a proportion transfer, like 1/4 is a proportion of something, right? So we draw right now a BCA. So we started off with 4 units. Your change would be -1. Then you're left with 3 units. Okay, here total after the transferring, 308. Okay, so before I move on to basket B, I want to find common base first. So between the first two ratios here, I need to have a common base, and the common base is your number of pairs at first. This ratio is talking about at first, we have pairs. This ratio is talking about pairs only, and we also have before. So that is your common base. They represent the same thing. Okay, so times 2 throughout to make it 8 for pairs at first. And now we figure out what is the total in the end. My total for kiwis, number of units, kiwis didn't change, so kiwis is still 5. Pairs would be how many units? Pairs in the end is your pairs after, which is 6 units. So here it's 5 to 6. So answer for part A, 5 to 6. Now for part B. Total in B in the end. Okay, let's look at B. B, the ratio at first. Said thrice as many kiwis as pairs. So in box B, kiwis, pairs, thrice as many, so 3 to 1. Then there is a transfer, right? Oh, sorry, not pair, not kiwis, but pairs. There was a transfer from basket A to basket B. So whatever B received, we're not very sure. Okay, we just know it's 1/4 of P. But here it doesn't mean that the pairs increased by 1/4. Because this 1/4 is talking about 1/4 of basket A's pair. Okay, then the ratio in the end became 7 to 5. So K to P, 7 to 5. Okay, let's use part A since we have common base for part A. Let's find out how much is it using this 308. Okay, sorry, hold on. For this ratio, this second set of before change after, there's also a common base here, which is your number of kiwis. The kiwis didn't change, right? So I'll change it to 21, common multiple. So this is also 21, this is a 15. Okay, so then back to this. This 308, right, is 11 units. Okay, let's call this units. Then let's call this parts. Okay, for units, 308 will be 11 units, cos 5 plus 6. Five U plus 6U equals 11 units. So 11 units is 308. Then 1 unit is 308 divided by 11, which is 28. Now I can find, what do I want to find? I want to find this part here. Okay, because that will tell us how many is this. So 2 units. Be 28 times 2, which is 56. So actually, this number here is 56. Okay, then we look at this one and this one, like the change. So what is the change? Let's call them parts. So 15 parts minus 7 parts equals to 8 parts. So that change of 8 parts is actually 56. Okay, 8 parts is 56. So 1 part, 56 divided by 8, which is 7. Total number of fruits in B in the end would be this 21 plus 15 parts. Okay, so 21 parts plus 15 parts is 36 parts. So 36 parts would be 36 times 7, 252. Okay, so this is for question 14. Now let's look at question 15. Okay, diagram figure below here is made up of a semicircle with diameter 12 cm and a rectangle measuring 12 by 16. So 2 identical semicircles are cut out from the rectangle. Using calculator value of pi, find the area of the shaded part. Now for the shaded part, right, this semicircle is actually the same as this. So if you shift it, then technically this is covered. So it's actually 1 rectangle minus 1 semicircle. Okay, so we are finding area. Area of semicircle would be using pi times radius times radius. So I need radius. Okay, so this is the formula that you should be using for area of circles. So for part A, let's find radius of the semicircle first. Okay, so 12 divided by 2, which is 6. Area of semicircle. Semicircle is half of a full circle, so you need to times half. Okay, half times pi times radius times radius. Now take note, if the question asks for calculator value of pi, in your working, you can give it in terms of pi first. Okay, you don't need to press the calculator value of pi until the very last step. So this will save you from writing a lot of decimal points. Okay, so half if you leave the pi alone, it's basically half times 6 times 6. Half times 6 is a 3. 3 times 6 is 18. So it's 18 pi. So one semicircle is 18 pi. Now I need to find the rectangle, and then I minus one semicircle. Okay, so after shifting this semicircle, it's actually one rectangle minus one semicircle. So your rectangle is 16 times 12, 192. So shaded would be 192 minus 18 pi. Now you use a calculator value of pi because it's in the last step. Now you should get something like that. Then you're supposed to round it to 2 decimal places. So 135.45. Because after the 5 is a 1, you do not need to round it up. Okay? So round it to 0.45. So that's your answer for part A. 135.45 square cm, since it's area. Next, for B, using calculator value of pi again, find the perimeter of the shaded part. Now, perimeter of the shaded part, what is it made up of? You have a 16. You have a 16. What else do you have? You have arcs or semicircles. Okay, this one you cannot combine. You cannot like close up the gap now. The semicircle, the arcs will be counted 3 times. Then take note that there is actually this part here as well. That is part of the perimeter. Okay, let's find the green ones first, the arcs. So to find arc, the formula would be pi times diameter. Arc will be half of that. So arc of semicircle using half times pi times diameter, which is 12. Okay, this will give us 6 pi. Okay, then now we'll find like all 3 arcs. So 3 times 6 pi. Okay, 18 pi will be the ones in green. Then how about the ones in pink? Pink. It will be 16 minus 12. Okay, then you get 4. 4 is the total of the 2 pink parts. Okay, you don't need to divide by 2. You want to find perimeter, so you need both anyway. Okay, now let's add everything up, including the 16 cm. Including this 16. So 18 pi plus 4 plus 16. Into your calculator, you should get like 76.5485, 5487, sorry. Then 2 decimal places. So this is the second decimal place. You need to look at the number behind. It's an 8, so you need to round it up, 0.55. Since this is perimeter, so answer in cm. Question 16, we have a trapezium, we have a square. AE is parallel to BD. AE parallel to BD. Okay, this one is also talking about the trapezium, because they said ABDE is a trapezium. Trapezium means you have one pair of parallel lines, which is in this case is AE and BD. Okay, then you need to find angle X. Now, let's find angle. Okay, you have a square here. Square, which means that this is 45. Because in a square, the diagonal will cut the right angle into half. So this is 45. So how do you find X? Now, this is your interior angle. So you have a pair of parallel lines. The sum of the angles in between will give you 180. Okay, so let's say I want to find ABD first. Let's do it step by step. So this angle plus this angle will be 180. So 180 minus 116 will give me this ABD. Which is 64. Then angle X is 64 minus 45. Okay, get 19 degrees. Question 17. Figure below ABCD is a parallelogram. Then CE and CG are equal, which they have already marked out. And DFG here, this one, straight line. You're given 97, given 26, given 127. Find CDG. CDG, this angle over here. Okay, we have parallelogram. Let's mark down all the parallel lines. They could be useful. So these two and these two. Okay, so first I'm going to use the parallelogram and find this. You have interior angles. I am going to find this DCB first, okay? Because if I can find this, then DCF, this triangle, I can use 180 minus this, minus 97 to get this CDG, part A. Okay. So for A, using your interior angles, I'll find DCB, which is 180 minus 127. They add up to 180. So this is 53. Okay, the angles between two parallel lines, they add up to 180. So 180 minus 127, they give you 53 here. Now 53 is DCB, and this is 97. So to find this, 180 minus the two angles in the corner. So C, D, G, 180 minus 97 and 53. Which is 30 degrees. Okay, so we have this 30 degrees. Answer for part A. For part B, find GCB. Where is GCB? Okay, this angle over here. Now, what I want to do first is I would want to find this angle here. Okay, because this is an isosceles. So I will find this angle here, then later I'll find this angle and I'll minus that. Okay, so yeah, let's find ECB first. For part B, E, C, B. 53 minus 26 equals 27 degrees. So this part here is 27 degrees. So can you see that in this triangle here, right, I got 27, I've got 97. I want to find this. So that's CEG, okay, angle CEG. 180 minus 27 minus 97, which is 56. Now, if this angle here is 56, then this angle here must also be 56. So in this triangle here, if I take 180 minus 56 minus 56 minus 27, I'll get this part here. Okay, which is what we want. Angle GCB. Yeah. This will give us 41 degrees. Okay, so answer 41 degrees. Okay, with that, it's the end of this paper. This is ACS Primary Topical Test 2.